let's start explaining why the requirement in our PV array standard, ASNZS 5033, says that all panels in the series connected string must face the same direction. Let's start with a problem where they don't. And this happened to me when I was flying into Melbourne one day, and I looked out the window and I saw a house, as you do now. If you look out the window in Australia, chances are you'll see solar panels on a roof, right? And I looked out the window, and just near Tullamarine Airport was a system that looked like this. Okay. Okay, so I did a rough count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 panels. This was the north facing, this was the west facing part of the roof. So they put most of the panels on the north and 2 on the west. Now there's no inverter that I can think of, even with 2 maximum power point trackers, where you can put just 2 panels on one tracker. The volts are just too low. So I'm pretty confident that someone accidentally created a one-string system like this. So they've got most of the panels on the north and a couple of spare ones on the west. The problem with this is that this is a pitched roof, right? So it's roughly 25-degree pitched roof. And let's say it's winter time, so the sun's relatively low in the sky. And it's 10 o'clock in the morning, so the sun's over here, and it's shining on these panels here. Now when you get direct sun onto a solar panel, its output current should be close to what it's rated at. So let's say these panels can put out approximately 9 amps. But the panels on the west aren't in the sun. They're actually still in partial, we'll call it low irradiance, it's sort of like partial shade. They're not getting direct sun, but they're getting reflected light from the sky. So it's probably only 10% as much as the sun is producing. So a little bit over 10%. So these panels notionally could only put out 1 amp because they're actually in the partial shade. But you can't have different currents in one string. So if these panels can only produce 1 amp and these can produce 9, this is not true. This will be 1 amp as well. The weakest link determines the current. So the problem with that is the mismatched orientation within one string is going to limit the whole thing, depending on the position of the sun. So that's the problem. That's why the standard says all panels in a series connected string must face the same direction. But let's fix this, and let's add another string.
And the same incline?
Plus or minus 5 degrees. Same azimuth and inclination, plus or minus 5 degrees. Yeah. So let's fix this problem, but we're going to add another string as well. So how many panels did I have? 10, right? We're going to probably just squeeze it in. Some inverters will work with just 5 modules in a string. We're going to put 5 on the north and 5 on the south, because I can't fit 5 on the west. So that's the south, that's the north, and we're going to connect them in parallel. Okay, and there's my inverters over here in the hot sun. So now we are complying with Australian standards. All panels in a single string are facing the same orientation. And let's say, once again, it's winter time, it's 10 o'clock in the morning, we've got the sun beating down on the north face, so we'd expect to get approximately 9 amps out of these panels. And the panels on the south side are in shade, or lower radiance to be more technically correct, so these can only put out approximately 1 amp. But because we've paralleled them together, those numbers add together now. You don't go to the weakest link, because they join at this point and go to the inverter. So we've now got approximately 10 amps going to the inverter. So that's fine. So having equal numbers of panels on different rows, as long as they all face the same direction, each series connection string, thumbs up. Incidentally, people say, yes, Glenn, you can do this, but it's not as good as having a dual tracker, is it, Glenn? Actually, not true. If there's no shading on this roof, like no localized shading, because there's a tree here that shades it in the afternoon, there's no performance difference. A dual tracker, a single tracker will give you the same amount of energy. Both SMA and Fronius, 2 of the most respected inverter manufacturers in the world, have produced academic papers with test results proving this. They're actually in the Dropbox, so if you want to read them, they're a bit scientific. They show that from empirical tests, there's less than a fraction of a % difference to having two parallel strings into one input or two separate strings. But that's only if you don't have localized shading on one of those strings. As soon as you get a bit of shading on one string, you've now got mismatched strings, you start to get problems. So it's probably better suited to new suburbs with no trees. Nice clear sky, roofs, no shading, no chimneys, no air conditioners, no satellite dishes have arrived yet, no TV antenna guys turned up and put it right next to the panels. Yeah, so there's lots of reasons that this won't work, but in some locations it will work perfectly well. There you go. You're allowed to do it.